All right, ladies and gentlemen. So today I want to show you some basics of geometry. All right, what you can expect to see in class, as opposed to what we were doing before, where we were drawing the circles. That's fun stuff. But what can you expect to see in your geometry class? Take your straight edge, if you will, please. Just try to make a straight line, and just make a straight line. Okay. While you're doing that, I'm going to try to adjust this camera a little bit so that it actually looks straight to the viewer. It's kind of gimbal and that. Adjust this a little bit. Okay, how many degrees is it from here to here? 180. Okay. So what is this called? Yes, it starts with a P. Protractor. Good. Okay. So if I put the protractor right on top of the straight line, I can measure off an angle. I've measured off an angle here, and that angle is 70 degrees. What you can expect to see in your classes when you actually take geometry is you can expect to see some kind of algebra over here. We know that the total degrees have to add up to 180. So what is this total angle going to be right here? It has to add up to 180. So what must this angle be? 110, right? But they won't give it to you like that. They'll say something like 2x. Okay, and this is where students go, oh man, they tricked me. I thought I was taking geometry, but they put algebra back in. And so the technique to solve this is to say 2x plus 70 equals 180. So you had to know the total angle would be 180. This is called a linear pair. And linear pairs have supplementary angles. Supplementary means the sum of the angles is 180 degrees. Okay, so whether they tell you it's a linear pair or they tell you the angles are supplementary, they add up to 180 degrees. So now they might ask you, what is x? Okay, and so first you have to determine what x is, and so you have to solve this little algebra problem. Subtract 70 from both sides. You already told me it would be 110. 2x equals 110. Divide both sides by 2. So x equals 55. Very typical geometry problem. Was that hard? No. All right, so let's keep playing with this shape. And I'll show you some other stuff that they can do. Okay, remember, this is still 70 degrees right here. Now they might ask you again, what is x? So now we have to learn something new. Do you see how these lines right here cross and make kind of an X shape right here? Do you see how the 70 degrees is mirrored from the 5x? This relationship between 70 and 5x, this is called vertical angles. Correct. So with vertical angles, you still have to show the work. But the work here would look like this. 5x equals 70. So we would divide both sides by 5. Let's see, 5 goes into 7 one time, with 2 as a remainder. 5 goes into 24 times, so x is 14. Now here's a question that can be done with the same picture. What is this angle right here? What's that angle measurement? Notice that if you were to take your vantage point, instead of looking at this picture like this, if you looked at it down like this, where this line is the bottom now, 70 forms a linear pair with this question mark. So what is the angle measurement of the question mark? You already said the number earlier. It's 110. Good. Because 70 is going to be supplementary with this angle, because the two numbers 70 plus question mark have to equal 180, right? Okay, now we're going to use our compass. So let's draw a circle. Again, the diameter of the compass, go from the tip of your finger to your knuckle. It doesn't need to be an enormous circle. My circle is not going to be as good as your circle. Now see if you can find where you put the midpoint at the center of your circle, and just draw a flat line going through the middle of the circle like this. And then draw a vertical line going through the middle of the circle. So you make a kind of bullseye looking thing like that. Does anybody remember the formula for the circumference of a circle? Yeah, there's two formulas you learn. You learn pi times the diameter, but you also learn 2 pi r. You remember that one? 2 pi r. We're going to use that formula. 2 pi r is the circumference of a circle. Now, that's the radius. The r stands for the radius. Let's assume that the distance from the center of the circle to the edge of the circle, from here to here, this radius, let's assume it is 1, just 1 unit. Okay. So now if I were to try to find the total circumference of the circle, it would be 2 times pi times r, where r is 1. So the total circumference, if I don't turn pi into 3.14, I just leave it as pi, would be 2 times pi times 1, which is just 2 pi. So now, when the radius of the circle is 1, the total circumference is 2 pi. So I have a question for you. What would half the circumference of the circle be? If the total circumference is 2 pi, what's half the circumference? 1 pi, or just pi? So notice how far around the circle we rotate counterclockwise. So take your finger, put it right here. Move your finger counterclockwise 180 degrees to here. And put pi. So we have here, we rotate all the way around here, we have pi. That's half the circumference of the circle. Okay. So what would a 1/4 of the circumference of the circle be? Remember, 2 pi is the total circumference, right? So if I just want 1/4, I would do 2 pi and divide by 4 to give me a quarter, 25% of the circle. You can simplify that down to 1 pi over 2. So this equals pi over 2. So that's, if we start back here and rotate 90 degrees, that's pi over 2. How about 75% of the circle, 3 pi? Sorry, 3/4 of the way around. Here we have 2 pi is the total circumference of the circle. I'm going to divide the total circumference into fourths by dividing by 4. And then I'm going to multiply by 3 to give me 3/4 of that's the circle, okay? So what we have here is, remember, this will reduce down to 1 over 2. So now I have pi times 3 over 2. So this is 3 pi over 2. Look up here again, please. 90 degrees of rotation puts us at 1 pi over 2. 180 degrees of rotation puts us at 2 pi over 2, which gives me pi, right? These cancel. 1 pi over 2 gives me pi over 2. Here I'm at 3 pi over 2. And here I'm at 4 pi over 2. See, that reduces down to 2 pi. 3 pi over 2 doesn't reduce. 2 pi over 2 reduces down to pi. 1 pi over 2 reduces down to just pi over 2. So this is called the unit circle. And the measurements we're giving here are called radians. So this is pi over 2 radians. And what radians are is the unit of measurement. It's like feet, inches, miles, radians. Radians is the measure of the circumference, like a part of the circumference. It's this distance on the arc. So if somebody told you, what is the total distance from this dot to this dot right here, you would say it's pi over 2 radians. Okay? See if I've got some room here. So when we talked about the whole distance around the circle is 2 pi radians. 2 pi radians corresponds to 360 total degrees. So how many radians are there in, let's say, 60 degrees? Let's say I'm asking you now, I want to know this distance here, this minor arc here. I want to know the distance from here to here. I want to know this distance, just this, like the edge of a pizza. I want to know the portion of the circumference of the total pizza from this edge of the slice to this edge of the slice. So that's where this comes in, the question mark. Okay, I told you this was 60 degrees. So we can put 60 degrees down here, and it becomes a butterfly thing, all right? So think of this like x. So we have 2 pi times 60 equals x times 360. We'll divide both sides by 360. And now we're working over here. How many times does 60 go into 360? Six times 6 is 36. So 60 times 6 must be 360. Yeah. So I can cancel out the 60 and cancel out the 360, and that leaves a 6. And now I have a 2 and a 6. I can reduce that by dividing both by 2. This leaves 1. 6 divided by 2 is 3. So now I've canceled everything out except this pi on top and this 3 on the bottom. So pi over 3 radians equals x. That means that for an angle of 60 degrees, I have pi over 3 radians that measures off this portion of the circumference of the circle. So the thing to take away from this is, if somebody asks you, what are the radian measurement, and they give you some degrees, they say, give me the radian measurement of 120 degrees of rotation. That would be right here. Somebody said, I want to know the radian for 120 degrees of rotation. You don't care what that number is. You just take 2 pi over 360, and you multiply it by whatever degree they gave you. So in this case, it's 120. Okay, so we can figure this out very easily. These, actually, let's leave the 2 pi there. 120 goes into 363 times. So this cancels, right? 120 times 3 is 360. So this leaves behind a 3. That 2 stays there. So it's 2 pi over 3. So 120 degrees of rotation. This huge slice of pizza, this big edge here, the radian measurement, if you were to walk along the perimeter there, would be 2 pi over 3 radians. Okay. All right. Well, so that's a little bit more about geometry. We just did a lot of stuff there. Okay. I'm kind of just throwing topics at you so you can get exposure. And if it was confusing, or if I'm really trying to get your feet in the water and all the different things you might do in geometry. This is one of the more advanced concepts. You might learn this in second semester. I hope you learn it. I hope it's not that you don't learn it at all. You should learn about the circle. Oh, he definitely did. I definitely remember all those discussions.
So, my class was one of the worst classes. We had a whole bunch of law players in my class.
Okay. All right. Well, listen. I hope you gained something from watching that. At least you've heard the word radians. You know about pi and 360, and the circumference and the unit circle. You've heard all these words. We looked at linear pairs, supplementary angles, vertical angles. We solved for variables. That's good.